you're a Tom Cruise fan, you should have seen him that he's pretty much fascinated by data centers and is always after them in his movies. Let's reiterate the definition, get back to scalability and elasticity. So what exactly is cloud computing? A style of computing in which scalable and elastic IT-enabled capabilities are delivered to you as a service using internet technologies. That's the definition by Gartner. Let's look into what is scalability and what is elasticity, the two key terms in this definition. Before I bifurcate these terms, let me tell you that I would be predominantly using two terms in this entire discussion: on-prem and cloud. Whenever I say on-prem, remember this image. It's an on-premise server room. You might have seen this server room in your corporate office premises. These boxes are servers stacked upon each other like products in a supermarket. There are spaces too in between them. This space is to accommodate additional servers for scaling. Whenever you add new servers to your infrastructure, you say you are scaling up the infrastructure. We'll come to the technical terms. So whenever I say on-prem or on-premise, imagine this image. And whenever I say cloud, imagine this image. This is a cloud data center. Azure has multiple data centers like this across the globe. All the blue dots which you see on the map are Azure data centers. If you're a Tom Cruise fan, you should have seen him that he's pretty much fascinated by data centers and is always after them in his movies. Let's reiterate the definition, get back to scalability and elasticity. Let's say we are working for a company called TaxPlan, and it is a portal which will allow you to file IT returns. You are my team member, I'm your architect. Let us say we work on this project together. Let us say TaxPlan is an on-prem solution and we are live with two servers. So two servers, two boxes in these racks are for TaxPlan. What about other boxes? These are the boxes which are used by other clients of our company. So we are specifically bothered about the two boxes in which TaxPlan is deployed. Let us say we are in the month of February and we go ahead and file the IT returns in the month of April. So we are 2 months away from hitting the peak. So I, as an architect, did the analysis by doing some load testing and stress testing. I came up to the conclusion that we need 3 more extra servers for our entire infrastructure. What are these 3 extra servers for? They are for the peak which our website would hit in the month of April. Now you would say, what does it mean by the peak of traffic? Amazon will not have the same kind of traffic during the regular season and during the Christmas season sales or during the Diwali season. It would be totally different. There is a huge spike in traffic during the Diwali season and the festival season. And what about any other season, like a regular day, like today? It will not have huge traffic. There would be still orders being placed in Amazon, but it would not be a huge spike. So every website has its highs and lows. Like Amazon has its peak, our website, TaxPlan, will also have a peak from April till August. What happens after August? The traffic will go down and it would be moderate. But from April till August, for a period of 5 months, I expect huge traffic. So I, as an architect, I went ahead and did some load testing and stress testing and came to the conclusion that we need 3 more servers. What all I need to do to go ahead and get these 3 more servers? Step number 1, I need to get approvals from all the stakeholders. Who are the stakeholders? The directors, the CTO, the COO. Step number 2, I need to procure or buy the servers from the vendor. Who is the vendor? In our case, let us say our vendor is in Germany. We need to buy the servers from Germany. Let us say we went ahead and placed the order. We are in the month of February. So by second week of February, we will get the servers delivered to our doorstep. So now I need to take these 2 servers and retrofit into the server room. Who would help me do that? The network engineers. Our company has to maintain teams of network engineers. Why teams? because we have to support the server room 24/7. So do the math. How many minimum number of teams would I require to go ahead and support the server room? If you said 3, the answer is correct. So how many 8 hours per day? 3 8 hours. So I would have 3 teams, 1 buffer team to actually have a router. These teams will have a router day in, day out. Every 8 hours, one team goes out, the second team comes in, and the team which is coming in would have a handshake. The team which is going out would go ahead and say, okay, these are the open tickets, you need to take care of it. And these are the tickets which are closed. And the team goes out, the next team comes in. So there is a router of teams of network engineers in your company. Cost to all these teams with entire hierarchy has to be managed by our company. So let us say I take the help of network engineers, get the servers retrofitted into the server room. So I have them fixed in the server room and I increase my number of servers from 2 to 5 because I got some 3 extra servers. What is the next thing which we need to take care of? The power supply. It has to be an uninterrupted power supply because we need to maintain the server room. Who is paying for the power supply? The company is paying for the power supply. Finally, the rent for the room. Who is bearing it? The company. It is a cost to the company. Now you would say the entire building belongs to the company. Why are you calculating the rent for the room separately? Let us say we are a service-based company and we have 3 different projects in a floor. The company goes ahead and bills the client the space occupied by their employees. Let us say project 1 employees occupy 1,500 square feet of space. That square feet of space rent is being paid by the client. So I would go ahead as a company, extract the money out of the client for the space occupied by their employees. But because of the server room, is it owned by or being rented by any of the client? No. I as a service-based company, I have to maintain it. So who is paying for it? I. So it is a cost to my company. So I would take the rent for the room separately. So what are the 5 things which we need to get? Get approvals from the stakeholders, go ahead and procure the servers or buy the servers, go ahead and retrofit the servers into the server room with the help of network engineers, have a unique and uniform power supply, and have the rent for the room being paid monthly. These things are the things which I need to take care of if we are an on-prem infrastructure. Let us say we took care of all of that and we went ahead and hit the month of April. So my estimate as an architect was correct and we were able to handle the traffic pretty efficiently. So the 5 server cluster actually went ahead and helped us and we were able to handle the incoming traffic pretty efficiently. Brilliant. What about after August? From September, the traffic would go down and I no longer require these extra 3 servers. Can I send them back to the vendor? I cannot. That is one of the problems with on-premise server room. I need to go ahead and have ideal servers. What are ideal servers? The servers which are doing nothing. They're just sitting idle. Are there other challenges to the on-premise ecosystem? Absolutely. There is too much of cost to the company. Apart from the cost, imagine during the pandemic, all these social media websites like YouTube, Instagram, Facebook, all these were on-prem solution. Did they get huge traffic during the pandemic? Absolutely. If they were an on-prem solution, would they be able to buy the servers and retrofit the servers in the server room? The extra servers needed to handle the traffic? They would never have been able to do it. They were cloud-driven since day 1. Because of that, they were able to efficiently handle the traffic and scale up the infrastructure. Now, let us understand it with the same example of tax plan. Let us switch the case. Let us say a tax plan is a cloud-driven solution. The use case is exactly the same. We are a IT returns portal. We are live with 2 servers and we are in the month of February and I need to go ahead and do the load testing to go ahead and see what is the amount of traffic which we can expect in the month of April And according to my analysis, I came to the conclusion that we need 3 extra servers. So we go ahead and scale up the infrastructure. Adding extra servers to the infrastructure is just an edit to a text box in the cloud. I would show you how simple it is in our coming videos. You just need to change a number in a text box and hit the save button. That is, when we went live, we were 2 servers. Now I want to scale up, which is I want to go ahead and add extra servers. So all I would do is edit the text box in the cloud and make it 5 and hit the save button. I am 5 servers strong now. What is that? It's just a simple text box edit. Did we escape all the things what we did in the premise as a on-premise solution? Absolutely. Just rewind and see what all I need to do if I was an on-premise solution. In the cloud, it is just a simple text box edit. That's about it. That's what you do to go ahead and scale up your infrastructure. This adding of extra servers to your infrastructure is called scaling. You scale the infrastructure. And once we are done with the peak from April till August, in September, I would like to scale down. That is, I would go ahead and remove the 5 from the text box, make it 2 again, and hit the save button. That would get back my infrastructure to 2 servers, and Azure will only charge me for the extra 3 servers from April till August. Did I scale down by just doing a simple edit to a text box? Absolutely. It is as simple as that is. That's what is scaling. You scale up, you scale down your infrastructure. This is scaling. When you scale up and scale down, you can see that there is a flexibility in the cloud. This flexibility which cloud offers is called elasticity. That is, the cloud is elastic in nature. You can scale up and scale down, and the cloud is elastic. So what's cloud computing? A style of computing in which scalable and elastic IT-enabled capabilities are delivered to you over the internet. How is it possible that we, sitting at our home, are able to access these data centers across the globe? Let's look at it in our next video. Do like, share, and subscribe to this channel, Bot Campus AI, for more in-depth dives into AI and machine learning and the tech that keeps them running. I'll be sharing tutorials, comparisons of different cloud platforms for AI and machine learning, and even some tips and tricks to optimize your workflows. Thanks for watching. I'll see you in the next video.